ជាដំបូងសូមគោរពជំរាបសួរទៅកាន់លោកគ្រូអញ្ចឹងពួកខ្ញុំមកពីក្រុមទី1ហើយពួកខ្ញុំធ្វើ project Automata នេះដោយប្រើ C++ ក្នុងការធ្វើវាអញ្ចឹងសារៈក្រុមខ្ញុំគឺពួកយើងធ្វើទៅលើការបង្កើត FA check DFA និង NFA test ថាវា accept recovery reject ហើយនឹង construct វាពី DFA ទៅកាន់ NFA ហើយនឹង minimize វាហើយនឹងធ្វើការ load file របស់វាទុក store ទុកនៅក្នុង file txt ផងដែរអញ្ចឹងចូលមកដល់របស់ខ្ញុំគឺខ្ញុំធ្វើទៅលើ create new FA ហើយនឹងធ្វើ load file ហើយនឹង delete file អញ្ចឹងសម្រាប់ខ្ញុំគឺខ្ញុំធ្វើទៅលើ C++ អញ្ចឹងខ្ញុំ design នៅក្នុង terminal ដែលទីមួយហ្នឹងគឺខ្ញុំបង្កើតជា grad new FA មួយដែល grad new FA ហ្នឹងគឺយើងមានពីរជម្រើសពី option ឲ្យគេរើសគឺ DFA ហើយនិង NFA អញ្ចឹងយើងអាច input យកមួយណាដើម្បីបង្កើតក៏បានដែរអញ្ចឹងយើងបង្កើត function មួយដែលមានឈ្មោះថា DFA ហើយនិង NFA អញ្ចឹងសារៈ function ហ្នឹងគឺយើងបង្កើតវាទីមួយគឺយើងបើក file Automata txt ហ្នឹងបើសិនជាយើងមានគឺយើងនឹងបើកដល់ហ្នឹងហើយយើង input ID first name របស់វានៅក្នុងហ្នឹងហើយពួកខ្ញុំបានបង្កើតជា queue មួយដែលយើងប្រើ link list នៅក្នុងហ្នឹងហើយគេអាច input among state នៅក្នុងហ្នឹងឬក៏ among symbol នៅក្នុងហ្នឹងហើយមាន start state ហើយមាន final state ដែលគេត្រូវ input អីជាដើមហើយនឹងយើងធ្វើជា transition មួយដើម្បីឲ្យ user គាត់អាច input បានថាត្រូវទៅ transition មួយណាហើយចុងក្រោយនៅពេលដែលគាត់ input ហើយអស់គឺយើងមានជា table DFA មួយដើម្បីអាច show ឲ្យពួកគាត់ឃើញថាពួកគាត់បានបង្កើតហើយអញ្ចឹងបើសិនជា NFA គឺយើងធ្វើដូចគ្នាយើងបើក file Automata មកបើសិនជាយើងមានបើសិនជាយើងអត់គឺវានឹងបង្កើតចូលទៅក្នុងហ្នឹងហើយបើសិនជាវាជា NFA វានឹងចូល NFA បើសិនជាវា DFA គឺវាចូល DFA ហើយយើងបង្កើតជា print NFA ហើយនឹង DFA មួយដើម្បីបង្កើតឲ្យវាមាន table នៅក្នុងហ្នឹងថាយើងបានបង្កើត table នៅក្នុងហ្នឹងហើយវានឹង print ចេញជា DFA ហើយនិង NFA ហើយសម្រាប់ load file វិញគឺយើង save table ទាំងអស់ហ្នឹងគឺនៅក្នុងហ្នឹងអញ្ចឹងវានឹងចាប់យកអីដែល data ពី DFA ឬក៏ NFA ហ្នឹងគឺចូលទៅក្នុង table ហ្នឹងចូលទៅក្នុង load file ហ្នឹង
Hello again everyone. Today I'm going to explain how to check if an automata is a DFA or NFA using our code. Let's start with a brief overview of DFA and NFA. A DFA or a deterministic finite automata. Automaton is a finite state machine where each state has exactly one transition for each input symbol, and NFA or non-deterministic finite automatons can have multiple transitions for the same input symbol, including ellipsons and transition. Okay, now let's look at code to check if an automaton is a DFA. That is DFA. Functions take the transaction tables as an input and check if the state and input symbol pair has exactly one transitions. If any state has multiple transitions for the same input symbol, it is returned false. Indicate it's not DFA, otherwise it's returned true. Similarly, the is NFA function check if any state have more than one transactions for the same input symbol. If it finds a case, it returns true, indicate the automaton is an NFA. Okay, now let's look at the check NFA or DFA functions, which is integrate the previous two functions to determine if the automaton is a DFA or an NFA. First, let's take the user input for state and symbol, and then construct the transition table. And next is filled with you can see here the for construct auto and state things here. Next is filled with the transition for each state and symbol if there are ellipses and solutions is a flex. Finally, based on the percent of epsilon transactions and the checks for is DFA and is NFA, it print whether the automaton is DFA or an NFA.
States are rejected. So in order to do this, we have a function called test as fa string, and in this function we first open the txt file, and then after that we call out the input dfa1 function. This function allows user to input states and symbols, and then we call out the function printable, which is print the states and the symbols into a table for summary. And then we have while loop. The purpose of this while loop is in order to let user test the string again and again. After that we have the for loop. The purpose of this for loop is to perform the logic in order to test the string index by index one by one to check whether it is in the final state or not. So after the for loop, we're gonna have a conclusion, and if it is accepted, if the display string is accepted, otherwise if the display string is not accepted, and then we're gonna close the txt file. After that, exit. So here is a quick example. So this
So for my part, I did on conversion NFA to DFA. The first step, we need to prepare the input data which contain detail of our NFA. And this one include the number of state and a public size and transaction for each state. And this is the data that I will test it. If you see in default, the first line specifies that an FA has 3 states and 2 public symbol. For step 0, there is one transaction on A to state 2 and one transaction on B to state 1. There are no epsilon transaction. For step 1, there are no transaction on A, one transaction on B to state 2 and one epsilon transaction to state 0. For step 2, no transaction on each other A or B and no epsilon transaction. Next step, I will compile this program for test our process to convert NFA to UFA. And this code will
Specifically focusing on the functions that handle all the input and minimization of DFA, we break down each part of the code to understand how it processes and connects the different components necessary for DFA minimization. So for the input DFA, for the minimize, here we initialize the state name starting with A and set up the variables to hold user inputs for transitions and states. We also allocate memory for an array to store the final state. For the user instruction, here this section prints out detailed instructions for the user on how to input DFA information, including the format for input symbols and transition. Also, the input number of symbols and state. Right here, we prompt the user to enter the number of input symbols and state for DFA. Specify the start and the final state. Also, the start state is predefined as A. The user is then prompted to enter the final state, which is right here. For the input transition, which is using the loop through each state to input transition, we loop through each state and symbol to collect the transition from user. The transitions are stored in the DFA tab table, which is right here. And for the function minimize DFA, which is down here at the code line of 900, right here to create minimize function. So this function orchestrates the minimization of DFA. It clears the console, collects DFA input, and performs the minimization process. To clear the console and open file, we write system and open the file, and then we clear it again. So we clear the console and open the file to append DFA details. This is done twice to ensure that the console is clear for the new information input from the user. For the input DFA right here, we call it this input DFA function to collect the user's input for DFA. And for the print original DFA table, we call the print table DFA tab, which is uses the original DFA transition table is printed to provide the visual presentation of DFA before minimization. For optimize this FA, which is right here, this optimize DFA function is called to perform the minimization of DFA. So this function returns the number of states in the optimized DFA, and then we get the new final state. So this function is to update the final state based on optimized DFA, and then we print the optimized DFA transition table. The minimized DFA transition table is printed to show the optimized version of the DFA, and then we choose the file. And then we close the file. So in summary, the input DFA function is called to collect the user input to define DFA, including the state, symbol, and transitions. And also by clearing the console, collecting DFA input and printing the original DFA table, minimizing the DFA, updating the final states, and printing the minimized DFA table. This ensures a clear and streamlined process for the DFA minimization. So this is the end of explanation. I hope this detail will through and helps me go to the demonstration of the code. So just let me heal it first and then run it.